Hi class, in this video I want to walk you through problem number 13 on your homework. Okay, so the problem goes like this. The data below represents the length in miles of a random sample of tornadoes in a specific area. Okay. This length represents the number of miles a particular tornado was on ground. I used the data to complete parts A through D below. Okay, so the first thing is it says right here, click the icon to view the table of tornado lengths. You can see all the lengths here in miles, okay? So part A says, draw a histogram of the data and comment on the shape. All right, so we have all these different histograms to choose from. So what I'm going to do is I'm going to click this here. And this double pane window will allow me to open it up in StatCrunch. And I'm going to go graph, histogram, because that's what it was asking for. I'm just going to select the first variable. I'm going to hit compute. And this is what our histogram looks like. Okay. So going back to the problem, obviously was part B, or option B. So got that. And when you talk about what this histogram looks like, when it has a little tail that shoots off to the right, this histogram is obviously skewed right. Excuse me. All right, draw a box plot. Are there any outliers? So if we go back to StatCrunch here, using our graph, there's an option for box plot. So we're going to click the first bar and go down in here and click on draw box, or click on boxes, draw boxes horizontally, because otherwise it'll draw it vertically. So I'll hit compute. And it looks like, so these little dots here, 1, 2, 3, 4, what these little dots here represent, these are the outliers. So whenever you have a box plot with these extra dots, that means there's outliers. So going back, it looks like this was our option here, A. So we got it. And are there outliers? Yes. So the deal is there are several values that fall below. The outlier requirement is you take 1.5 times the interquartile range and you subtract it from Q1 and you take that value and you add it to Q3. And any numbers past that or below that, those values are outliers. So we got it. So part C, based on the results of part A and D, explain why a large sample size might be desired to construct confidence intervals for the mean length of tornadoes in the area. Well, you need large sample sizes because the population or the distribution we have here is not normal. So once you take a sufficiently large sample size, the central limit theorem tells us the sampling distribution of the mean will be normal, and we can calculate confidence intervals around that. So looking at this, you just have to read through these and figure out which is the best one. The results of parts A and B indicate the underlying population is non-normal. Such populations require large sample size to construct valid confidence intervals. So we got that. So part D, use statistical software to construct a 99% confidence interval for the mean tornado length. So all you're going to do is you're going to load up here. You're going to go stat, tstat, one sample with summary. Oh, excuse me, with data. Sorry. So stat, tstat, one sample with data. Forgive me. So click on this. And it wanted a 99% confidence interval. So we'll go down here, change this to 99, and we'll hit compute. And we got our lower and upper limits right here. So looking at this, we are 99% confident, okay, that the population mean length of tornadoes is between, so it said round to 2 decimal places. So when I round this, it'll actually be 2.10. And going back, 4.63. All right, let's check. We got it. All right, class, I hope that helped for this problem.